Hello everyone, welcome back again for the classes. Today we're going to explore the sensor Sonar, and my name is André Dias and I'm from Academia de Robotica. This video is supported by the project Erasmus Discovery Robotics via STEM. And for starting, let's discuss what are the goals for today. So today we're going to explore how to use this sensor that is very apply in robotics that is called Sonar, okay? Where we can use it, and next we're going to learn how to integrate the sensor Sonar, the information provided by him with Arduino, and then we're going to have some challenges how to use Arduino and Sonar together, okay? So for starting, let me detail what material you should have with you to do this class. You're going to need to have the microcontroller Arduino, and in this case, I'm going to use Arduino Uno, but you can use in your home or in your school the Arduino Nano or Arduino Mega. You're going to need two LEDs, one red and another green, two resistors, a breadboard. Of course, you're going to need the sensor Sonar, this one, like here in the figure, and a buzzer. In case of the buzzer, you can avoid for now, because it's just for the challengers that I'm going to leave as homework to do in your school or in your home with the material that I have here in the list. And don't forget that, of course, to do this, you need to have the M-Block software in your computer. For now, let's start by discussing a little more how the Sonar works. As you can see here in the figure, the Sonar has two spots. One spot is the transmitter and the other spot is the receiver. As you can see here, it is acoustic sensor. So it's going to propagate sound, and the sound is represented here by the red lines here. So the sensor is going to propagate the sound and going to receive in the receiver the echo provided by the obstacles that are in the front of the sensor. So it propagates sound and receives the echo, and the distance between the transmission and the receive is going to provide to the sensor the information of the distance that is between the sonar and the obstacle. We have some animals, like the ones that I show here, the bat and the dolphin, that use the same principle for detecting animals or detecting obstacles in front of him. So they do the same. They propagate the sound, like here the bat is propagating, are the yellow lines, and the lines going to intersect, for example, in this animal, and the echo is going to represent by the red lines, going to be the information that the bat receives. With this time traveling of the sound and the received echo, the animal is able to detect obstacles and use this for hunting and for navigation. And this principle is denoted by animal echolocation. So this behavior that he has is called animal echolocation. So I introduce here two information. Well, one is a trigger, an echo acoustic signal, and the other is the echo, that is the return information from the obstacles that are in front of the animal or in front of the sensor. So let's see how to use this in our real life. For example, in robotics, this information can be used for the robots to detect obstacles. I have here one example of a robot that is a drone that is equipped with 4 sonars. This means that it's able to detect obstacles in all directions. So in all directions that the drone is navigating, is able to detect the distance between him and the obstacle. And as you can see here in the video, you can see that the operator sends the drone in direction to the wall, but he avoids colliding with the wall. It's important to say that the sensor only provides the information between the sensor and the obstacle. So it provides a distance. And the embedded computer will be responsible to take that information, and in this case, to change the robot behavior and avoid colliding with the wall. Okay. Another example of application of this can be in a ground robot navigating inside of a maze. A maze, it's an arena where there are several walls, and the robot must navigate without colliding with the walls. And in the presence of situation where he's not able to navigate, he need to choose what is the best alternative course that she should follow. As you can see, it has 3 sonars, one sonar in the front, one sonar in the left, and the sonar in the right. And the robot is continuously using the sonar in the front to see when is one situation where he can collide. And when he see that in front of him there is an obstacle, he measures the distance in the left and right to see what is the best alternative trajectory that the robot can perform. By doing this continuously, the robot is able to navigate inside of the maze without colliding with the walls, and at the same time moving without continuously and try to find what is the best path during the maze navigation. In our days, we can find this sensor, the sonar, also in free parking spaces, for example. Normally, this sensor is assembled in the top of the floor and is measuring the distance between the top and the ground. And when the car is in a spot or space, the distance value change, so they switch the light from green to red. This is 3 examples, but there are much more examples where we can use this sensor to help us to be more smart. Now let's see how to assemble and integrate this sensor with Arduino Uno. As you can see here in the figure, we're going to use wires with different colors, one Arduino Uno, and the breadboard, and also the sonar. I'm not going to detail the breadboard principle or functionalities because you have available in previous video the information how to use breadboard. But as you can see here, the sonar is composed by 4 lines. One is VCC, GNG, the trigger, and echo. The trigger will be responsible, is going to be a signal that Arduino is going to send to the sensor to request for a measure. And the echo will be the answer with the distance between the sonar and obstacle in front of him. There is also the VCC, that is the power supply represented by the red, that is connected to 5 volts, and the black line that is called GND, that is connected to GND from Arduino. For programming, we're going to use mBlock as I show you in the previous video. To do that, we're going to use a block that is called read ultrasonic sensor, and we're going to define 2 pins. The trigger pin, number 4, as you can see here, trigger is connected to number 4, and the echo pin that is connected to pin number 5. Okay, pin number 5. This means that with this block, we can use in several sensors, sonars. We just need to change the pins that we are indicating here in the configuration of the block. But this block doesn't work alone. We need to store the information from the ultrasonic sensor in one variable that we're going to call them distance. So we need to create in mBlock one variable called distance, and will be inside of these variables that we're going to store the information. To complete this and be able to see the information that Arduino is receiving from the sonar, we're going to use another block that is called serial write here, and we're going to replace this message that says hello with the information from distance. But now, let's do it in mBlock and also assembling the circuit, okay? I'm going to switch the channel, okay? And start assembling. So for starting, we're going to position the sonar here and create the connections between Arduino, the power supply between Arduino and Emblem. I'm going to use the colors that you have in the schematic available in the slides, but you can use other type of colors, okay? It's just to be more easy to understand the connections. It's important to make reference that the circuit available in the slides, the sonar is assembled in the opposite direction. We are put in this direction because it's more easy for you to take measures and see the sonar working without having these wirings in front of them. Okay. So at this moment we have the wires connected. The next step is to connect the trigger and echo pin. The echo pin is the green one. And the echo is going to be connected to pin number 5. Okay, pin number 5. Okay, and the trigger line is going to be connected to pin number 4. Okay. Now let's look to the code that we need to develop. For starting, we're going to use Arduino programming. Okay. Make sure that you already have connected to Arduino. Okay. And then we're going to use Arduino program, do loop forever. Okay. I have already here the variable distance, but I'm going to remove to explain how to do it. So we need to choose make variable. We're going to go on distance. And as you can see here, when we create the variable distance, the M block provides us 4 new blocks that are going to be important for us. In this case, and we need to use the set distance here. Okay. And pick the block read ultrasonic sensor, and in this block we need to change these pin numbers to the pins that we decide to use it. So for the trigger will be pin number 4, and for the echo will be pin number 5. And connect to the set distance block. So at this moment, what is going to happen? The read distance is going to acquire one distance and store inside of the variable distance. Next, we need to see what is the distance that Arduino is receiving. So I'm going to add this block that is called serial write text and replace the hello message by the distance. Okay. To make sure that we are able to see the information continuously, I'm going to add here a weighting of 0.5 to make sure that we are able to see the message that Arduino is receiving. Okay. Next step is to upload the code. Upload to Arduino. It takes some seconds. And then let's see how to receive this message. As you can see here, we have a block that is called serial write text distance. So to make sure that we are able to receive the information from Arduino, we need to connect again, because after uploading, Arduino disconnects. Connect again here, as you can see, and you're going to start seeing in this shell some messages that are written in hexadecimal way. To make sure that we change from this to char mode, this char mode means text, we need to change here to SHAR mode. As you can see, you start receiving one distance. I'm going to put my hand in front. This means at this moment, there is an obstacle 17 centimeters from him. I'm going to change that value. And then we are receiving 5 centimeters from my hand. If I decrease, more near and more far. Sometimes you see 0 there because my hand has fingers. And when I open my fingers, the distance, the way the sound is propagate and change the correct value to measure the distance. So you should use some solid object in front of him to make sure that the measure is more constant. If I take my hand, is detecting another obstacle that is in front of him. Okay. I'm going to change again the share. Okay. And this is the code that we perform in mBlock. So we have Arduino program, the loop forever. We create a variable that is called distance that is going to be responsible to acquire the information from the ultrasonic sensor and store inside of variable distance. And we have here serial write distance. In my code, I had here another block that was waiting 0.5 seconds to make sure that we are able to see the information slowly. Now, let's go to the challenge. As I said previously here, there is a real application in nowadays that is called free parking space, where in places like shoppings, we have one LED that indicates if the spot is free or not. And normally, the sensor that is responsible to measuring the distance is the sonar. So let's do the same. Okay, so the goal is read the sonar value, and if the distance is lower than 20 centimeters, we want to turn the LED to red. Otherwise, else we're going to have the green LED on. For starting, let's assembling in the breadboard the 2 LEDs that we need, one green, one red, and another green. One red and one green. As you can see here in the figure, we are connecting the green LED to pin number 7 and the red LED to pin number 6. Okay? Please start doing. I'm going to do the same and share with you. Okay? 2 LEDs, one red LED. One resistance. Don't forget that we are connecting the pin positive of the LED to the resistance and the negative pin to the negative line here, this connection. So we need to put one wire here is going to connect to pin number 6 in the case of the red one. And for the green, we're going to do the same assembler. So the negative pin is going to be here. One resistance, like the one you see here. one negative wire between the negative pin of the LED and the negative line here in the breadboard. And then we need connection between the green LED and pin number 7. So at this moment we have two LEDs, one LED green and one LED red. The green LED is connected to pin number 7 and the red LED is connected to pin number 6. So let's switch again. So I put here some blocks that can help you see what type of information that we need. So we need to store the distance from the ultrasonic sensor in this variable. And we need to use this block to take the decision. So if the distance is below one value, we want one color. If the distance is higher than this value, we want another color. So the next step is to implement the code. Don't forget that if you want to put the LED on, you need to use set digital pin, the pin correct, and set high to make sure that LED turns on. Okay. It's back again to the M block window. Okay. And let's see what you need to change here. So if you remember, we have here the distance. We have here the value. We can keep this instruction to see what is the distance value that you are receiving. And now we need to create a block that is called if and else. So what the rule says, if the distance is below 20 centimeters, what we need to do? We need to, if distance is lower than 20 centimeters, we want to turn on one LED and turn off another LED. So if you remember, if the distance is below than 20 centimeters, we need to turn on the LED number 6, that is the red one, and turn off the green LED that is responsible for pin number 7. Else, if the distance is higher than 20, we want the opposite, low 6 and high 7. Okay? This is the correct approach. I just want to add here another important information. Sometimes the sensor, when is not detecting nothing in front of him, will give us 0. To make sure that when we don't have nothing in front of him, we don't have that problem, we need to have here as an instruction that if the distance is something more than 0 and less than 20, this means that we have something in front of us that could be between 0 and 20. Okay, this is going to allow us to make sure that when the sonar doesn't have nothing in front of him, is going to keep green. Okay, next step, upload this to Arduino. Okay, at this moment we have green. And when we put our hand in front, it switches to red. Green, okay, is doing as we say here. If the distance is below 20, is putting the red pin high. Otherwise, is putting the green LED high. Switch to red, switch to green. Okay. Of course, that we are using a LED to represent this behavior, but this could represent, for example, when I have one obstacle in front of him, the robot stops the wheels. Okay, for safe reasons and for not colliding with some person, for example. Or, for example, if you are doing a parking system, car assistant parking, when I put my hand in front, or it can represent that the distance is too near, so it starts, for example, doing some noise saying that the distance is very near with the buzzer. This was just in one example how to use it and how to make one instruction like if and else to make a decision. If the distance is below than 20, turn the red LED on. If the distance is more than 20, turn the green LED on. Okay. Now I'm going to switch again. To the slides. And now I'm going to challenge you to do one car parking assistance. It has homework for you. So the goal is to perform the following. You're going to simulate that the sonar is assembling in your car, and based in the distance, we want to change the sound that your system will perform with the buzzer. I provide here some tips how to perform sound with the buzzer. As you can see here, you can use this instruction, play tone 10. This is the note. This note I choose this one because it's similar to the noise that the cars normally do with the parking assistance system. And here I'm changing the beat. The beat will represent the intensity, how many beeps we are doing with the buzzer. So try each one of them to understand what is the difference between beat 25, beat 100, and beat 500. Okay, and I challenge you to do this as your homework, where with the distance that you are receiving from the sonar, change the buzzer behavior in order to simulate a situation where you have a car parking system and the car is moving in direction to the wall, and we want to increase the intensity of the beep to make sure that the car driver knows how to stop, when should stop. Okay? Well, I hope everyone enjoy this class, and see you next time with more adventures in robotics with us. Bye.